camera just went off. This is what we're doing today is we're going to play 5 games. Briefly cover 5 games for the whole family. And these are games that you can literally play at some level with, or we've certainly got examples of games that you can play at some level with ages 4 to 99 plus, 100 and whatever, who's the oldest person in the world. It's actually, thinking about it, it's quite a great game to play with elderly people as well. Some of the games are suitable for elderly people depending where they are in their development stage, because yeah, if you work with any elderly people, you know what I mean about development, I think. So right, so we're going to start with a lot of these games are based on these 9 digits, 1 to 9. Not sure that any of them have a 0 in these particular games. I don't think there's any. I think they're all 9 sample pieces, 9 samples. And you'll see why I say that in a minute as well. So if you haven't played this game over the weekend, we've been playing this game over the weekend, and I'm just looking for the activity because I like to share it with as many people as possible. So I'm just doing a that's what's okay. Share on my timeline and putting that. So in the description is the link to the game. And with that link there are, as I say, 5 games in there, and it gives you, doing it as a family, whether you're an older learner helping a younger learner or you're an adult helping a younger learner, which I choose to view as an older learner anyway. I'm 58 years old and I'm always learning, and I love learning, and I love playing these games and learning by playing these games. Then it's great. It's a great game. It's a great game for families to play, and the realizations to have, and what you can do is there are questions in the activity. So if you're a younger learner, you're playing with an older learner, then you can get asked these questions. I'm going to be asking you these questions this time, but it's all in the activity pack. So download it. You don't need to print it out, just have it. And I'm also looking on here for this group because I suddenly realized I can actually hopefully respond to any messages that come in. Oh, that's not it. That's funny. Just got a very funny face that I pressed that. I know I pressed that, and all kinds of weird things came up. I pressed the group and other things came up. That's not my blue dress, so that's not me right now. There we go. Right, I can watch that now, and I can answer any comments on there. I don't know why I haven't been doing that. I know I started off doing that. Here we go. Right, so we're set to go. And first game number 1. What is game number 1? Game number 1 is the 15 game. This whole series is named after this first game. Now, we're going to play the game, but we're also going to figure out what we're actually learning. Like, this is a game. Why are we playing this as maths? This is making maths fun for kids of all ages. So why are we playing this game? Well, we're playing this game because, so is here, found it. We're playing this game because what it's helping us do is start to think, use all those life skills that we learn by doing maths. So, and being analytical about it. So we're going to play the first game, then I'm going to ask some questions. We'll play the second game. We're going to play it a little bit, ask some questions, and I'm going to, okay. So what we're doing is we've got 9 numbers, and there's 2 people. We're going to take it in turns. We're going to choose, each turn you're going to choose 1 number from 1 to 9. And the first person to get to 15 is the winner. So I'm going to start with 5. So we don't have 5 anymore. That's gone. And the next person's going to say, well, I'm going to start with 6. Fine. So this person then says, ooh, and you can only use 3 numbers. You've got 3 numbers. You can only use 3 numbers to get to 15, and you've got only these 9 digits. So they're all digits. So you've got 9 digits to choose from, and you can only use each digit once in the whole game. So each person, once that digit's been used, that's no longer available. So 6 is no longer available, and 5 is being a bit. 5 thinks they're being a bit clever because they've forgotten that that once they've put down 6, if you put down a 9, that's only using 2 digits. You've got to get to 15 with 3 digits, not 2. So actually, was that a wise move? But 6 thinks, oh, okay, you know what? I'm going to take the 1. See if you can figure out why. And then 5 goes. The first team goes, okay, oh dear, I'm not quite sure what to play now. So I'm going to play, it's going to go over. So I'll just go over the minimum amount. Maybe I can still win. I don't know. And team 2 goes, well, I think I'm going to play an 8. So first of all, has one of those teams managed to make 15? And the questions that I'm going to ask you are, the activity so we played the game, that's the game. Now, so these activities are for 7 to 18-year-olds, but you can play with the whole family. What I'm about to ask you is more for 11 to 15-year-olds, 11 to 14-year-olds. You can, if you hear the question and you think, oh yes, I can do that, then just do it. Doesn't matter what age you are. So what we want to do is write down all the combinations of these numbers that add up to 15 using 3 digits. So 3-digit combinations, and how are we going to write that down? Systematically, to make sure that we found all the combinations. That is super important. Every single game that we play, I want you to be thinking, have you encountered a game like this? We're looking for connections between the different games. And then remember, like team 2 forgot, you can't use 2 numbers. Who forgot? Team 1 forgot, sorry, that you can't use 2 numbers to make 15. You can't use 4 numbers. It must be 3 numbers. So all the combinations are 3 digits when you add them together to make up 15. So you write those down, that's an activity. And here's a few other questions to be thinking about it, be analytical about it, to come up with conclusions and be a mathematician, be a scientist, be curious. Is it an advantage to go first or second? And there's a question here. Can you work out how to play the game so that nobody can beat you? And then writing down, when you write down all the combinations, how can you be sure that you found all the combinations? Again, have you encountered anything like this before? Is there anything similar? And which numbers appear in 2 of the combinations, which numbers appear in 3 of the combinations, and which numbers appear in 4 of the combinations? So all the questions are in the activity. So download the activity, it's in the description, and you write down all the combinations, all the different possibilities. Then you'll be able to answer those questions. The questions are there. Just look at them. It's in the what they call the workbook at the beginning. And can you think of any other note games you know that are similar to this one? Right. Here's the next challenge, and this is your creative challenge. Make up a number game of your own. And you set the rules, and you can all create your own number game and share it, and then you can keep improving them. That's what we do. It's called iteration. You keep improving them and improving them and improving. That's how games are created. they're not, the first game that comes up isn't like the perfect game. You start off with an idea, and you think, oh, well, that's not perfect because of this and that. So you improve it. You say, well, if we did this, it would be even better. If we did, then sometimes you make it so complicated nobody can play it. So then you have to step back and simplify it a bit more. So go for it. Use your creativity and go for it. Right, now, next game. Next game is, now this game, it's in 45 minutes, we're going to do an activity for the early years and lower primary, so between the ages of 4 and 7, we're going to do an activity for them. But right now, we're going to do something for upper primary. Are you ready? Upper primary being ages 7 to about 11-ish. But you know what? I enjoy playing this game. I'm 58, so anybody can play this game. It's not necessarily suitable. It's not suitable for people that don't know their letters yet. This one really isn't, because not using 9 sets of numbers, 9 digits, we are using 9 words. I'm going to leave the numbers up there because we're going to use them again in a minute. But here are our 9 words. I like this one, laugh. You're having a laugh. So you can write down the words. Again, they're in the activity pack, so you don't have to remember them at all. You can always play the video again if you're not sure the instructions. If you prefer to see a video than read instructions. Right, those are 9 words. Now, instead of every 3 digits having to make up to 15, we're only allowed to use each word once. So once it's being used, that's it. And we use a different color pen for the next bit. And what the winner has to do to win is you have to have the same letter 3 times. So every word that you write down has to have 1 letter that's in all 3 words. Right, again, thinking about it as you're doing it. Is it an advantage to go first or second? And is there a way of always winning? Okay, so I'm going to start with eat, because I'm hungry. I haven't had my breakfast yet. So team 2 says well. I'm going to choose line because, cross out eat, cross out line, because that takes the E out, but also it gives me 3 letters that I can then possibly win with. Right, so team 1 says, right, we're going to take the I out. And team 2 says, well, I want to have N in all my words. So we're going to go with Anne. And team 1 says, okie dokie. I've got 3 words now. What about, oh my goodness? Oh, that's interesting. Let me see, wait, make sure I've got them crossed out. That one, it, Anne's gone. Oh my goodness. Oh, cool. That's cool. They both won. It was a draw. It was a tie. So everyone's happy. Yay. Okay, cool. So the objective is to win. See if you can do it. See how you can do it. Right, that's the game 2. And then again, the same questions as the beginning. The questions are in the activity pack. Go ahead and think about them. So write down all the combinations. Are you any games that you've figured out that are similar to it? And remember that you need to use 3 words, and in those 3 words there has to be one letter that is in all 3 words. So, and then again, make up a word game of your own. See if you can make words that follow the same rules as these. It doesn't have to be the same words, but you have to see what the pattern is, see what see what's repeated, see how many times each letter is repeated in how many words and things, that sort of thing. So analyze it and come up with your own game. Next, that's the word game. It's quite a mouthful, that game. It's called, hold on, where is it? It is here somewhere. It's called an online game. Okay, next. The next one, I'm going to go down, 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 bum, bum, boo, do, 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 bum, 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 boom. It's a magic square. Now, what's magic about a magic square? Using these 9 numbers, you've got 9 spaces in this, within the square, you've got 9 squares. Within that, you've got to use all 9 numbers, and you've got 1, 2, 3 columns, 1, 2, 3 rows. You've got the diagonal and the diagonal. So we've got 1, 2, 3, 4, 5, 6, 7, 8. There are 8 ways to combine. There are 8 places where you have to, those numbers have to add up to the same sum. And you've got only those 9 numbers. You cannot repeat the numbers. So each one can only be used once. You have to use all the numbers, and each row must add up. So if we add them all up, each row must add up to the same number. We're going to call that number Fred. The number Fred, well, maybe not Fred. We'll call the number N for number. It's going to be the same number. That number's going to be the same. That number's going to be the same. Adding all those up, that number's going to be the same. That number's going to be the same. That number's going to be the same. Adding boom, 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 that number's going to be the same. And boom, 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 the diagonals, that number's going to be the same. So they're all going to add up to the same number. So add them all together. And one of the big questions is there more than one option? How many numbers can N be? How many numbers? How many ways? First of all, how many ways can you get this same result with the same number? Also, how many different numbers can N be? These are all the investigations you've got around doing this. And let's see how many results we have. We've got 9 numbers. We've got 1, 2, 3, 4, 5, 6, 7, 8 possible sums. Going back to that first game that we did using 1 to 9, might be interesting to do some comparisons there. How many different ways could we, after you've played this game, compare it with the other games that you've been playing and see where the similarities are and where the differences are. We're looking for connections between these games. So I'm not going to do it for you. That's the challenge. And you can do this each individually and then compare notes afterwards. You can do it in pairs, working together. You can do it as a family, all working together. And just conversation, communicate about things, express your ideas, express your reasons. That's super important in any learning environment, and maths especially. And remember, there's no such thing as a mistake. Like, one of the things that I experience in life, I've had experience since I was a child, is that I make silly mistakes. But you know what? I don't make mistakes. I only make magnificent mistakes, because I always ask myself, what did I learn? And it's not and it's in where we share as a family with my grandson and his mum, we share the mistakes we made and what we learned from them. Because mistakes aren't a stigma. Mistakes aren't something you should feel bad about. Mistakes are to be celebrated because that's where we learn. It's like, oh my goodness, I've made a mistake. Opportunity to learn. That's what we're here for. We're here to learn. We're here to learn to live the best life we can. And that includes learning to think. And that's where this comes in. Right. Now, learning to think is a super useful skill, by the way, in life. Being able to think through a problem and not get stuck and not get like panicky or whatever, right? So you might come up with different solutions and find out whether they are different, what the differences, what are the similarities, and when you've discovered how many solutions they are, have a discussion about something quite interesting, which I'm not going to reveal. But there is something very interesting about it. And when you discover that thing, you will know what it is and discuss it as a group. Each person can discuss their own realizations and listen to everybody. It's super important, not just to talk, but to listen. Now, there's another, we've got a visual thing here as well. Are all the solutions, we're looking at rotations and reflections. So rotations being going round and reflections being across a line of reflection, that line of reflection, that line of reflection, and that line of reflection. So we're going to look for those patterns. We're going to look for patterns. We're going to look for reflections and rotations. Right, the next game is now, this one's a fun one to draw. Now, I'm actually going to, am I going to start with that one? Because the reason why it's fun to draw is because it's got to be symmetrical and I've got to do my best. Right, we're going to go from there to there, and that's a straight line. That's a straight line. And then from there to there is a straight line. And then we have some more here, which this one's a vertical line. And then we have two more lines here. And then two more lines here. Now I am actually going to color this a different color just to be absolutely clear. That is one line, one straight line, even though it's a bit rough on this board. Those are one straight line. So now we're going to put in the towns. These are roads in a town. That's one town, 2, 3, 4, 5, 6, 7, 8. This is starting to sound familiar. 8 towns. How many roads? 1, 2, 3. Oh, that's one road as well. 3. Let's mark that. There's one road. That's one road. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8 towns and 9 roads. Have we had those numbers before? I wonder what the connections are. Now, in each town, we have possibility. This town has 4 roads. This town has 1, 2, 3 roads. Are there any towns with only 2 roads? That's got 3, that's got 3, that's got 1, 2, 3, 1, 2, 3, that's got 3, 1, 2, 3, 4. Most of them have 3 roads, some have 4. Anyway, the challenge is to manage to color in, to own, so each one of us is going to color in, and the first player to color 3 roads that are going to or through the same town is the winner. So what color are we going to use? We're going to use green. because we've used all the other colors, few other colors. So I've got to keep my eye alert, and we've got to, one of the teams, team 1 or team 2. Oh, I've got to use 2 different colors. Hello. 2 different colors. Team blue and team green. Let's see. Well, team green's going to go here. Boing. Let's see if one of the teams has got to get 3 lines through the same town to win, or through or leaving the same town to win. 3 lines. Okay, well, team blue decides to do that. Team green decides to come down here, and team blue thinks, ooh, where can team blues decides that they don't want, team blue decides to come over here, and team green goes, aha, sorted. Team green manages to do 3 lines through that town there. So team green wins this. Well, actually, is there something that team blue can do to also get 3 lines? Oh, no, they've only got 1 line. This one goes through 2, but the other line's gone. So that other rose is gone. So there's nowhere that team blue can now go to make a tie. So team green wins. Okay, now again, we're looking for a winning strategy. Is it possible to avoid losing this game? Again, write down all the combinations. This is going back to the other one, all the combinations that add up to 15 in that first game. These are questions for all the games. And are there similarities? Look for the similarities and the differences between this game and the other games we're playing. Now, that's the challenge. That's what this is all about. Now, let me see, is there another game here? There is one more game. There is another game we haven't played yet. Now, I'm now talking to 16 to 18-year-olds. And talking to 18 to 16-year-olds, whichever way around it goes. What we're talking about here is there's something called isomorphism, which means iso means the same, morphism means changed. So they're the same, but they're different. They're the same, but they are a variation of each other, like they're morphed. So it's the same game morphed. That's the idea. And we're just going to look at this one. Now, this is something that you can play from a very early age. If you recognize that, Tic Tac Toe or Noughts and Crosses. And I'm going to start by playing an X here. So the other team is going to play a Naught. So X has decided to go here. And Naught wants to win, so Naught thinks, oh, I've got 2 in a row there, and X goes, I'm going to both stop you, and I'm going to win. Yes. So X won that one. So again, the same questions. Is it possible to find a winning strategy? What is the winning strategy? What are your ideas? Is it possible to avoid losing the game? And have you seen anything like this? Now, what have we got? We've got 1, 2, 3, 4, 5, 6, 7, 8 possibilities to win. And how many spots? How many squares? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. Have we seen this before? This is the question. Have we seen it before? Over to you to think about it, to discuss it. So the older you are, the more we're talking about the connection. So now I'm talking to 16 to 18-year-olds. It's the concept of isomorphism. I've got my lovely friends, Tony and Alan. that they are proper mathematicians. Me, I'm an engineer and I'm passionate. I believe that every child on earth should love learning and enjoy mathematics. I don't write these activities. Tony writes them, and other people on the AIMSEC team write them. And all these activities are home learning guides that are available on the Amy High website. And what we've done so far, we've covered from some, I mean, obviously, even my 5-year-old grandson can play this game with me, but making those connections, that's the important thing. My friend Alan talks about you can make connections in geometry with things that happen in algebra, and for example, and things that you would think wouldn't be connected at all. Suddenly, whoa, you see that isomorphism, and you want to be looking. This is why the more knowledge you have, the more understanding you have on all the different areas of maths and science and how the world works. Even looking at molecules, you start to see connections, and you get a deeper understanding whenever you see those connections. And you, and I do mean I'm looking at you could be the person that makes the next big discovery. It doesn't have to be a big discovery. It can just be an insight which shows a connection between two things that nobody's ever thought of before. And they can be super simple, but it's like moment of bing, light bulb. And you could come up with an idea and actually it turns out either somebody's already thought of it or there was something missing that you didn't know and somebody else will look at it. That happens with mathematicians all the time. Proper mathematicians like my friend Alan comes up with ideas and then talks to different colleagues, and then they think, oh, okay, yeah, no, there's this little factor. Have we thought of that? No, we hadn't. All right, it doesn't work. But that's when mathematicians get excited, is when they're working on a problem that nobody's solved or that nobody's thought of. It might not end up being a new discovery, but it's exciting because they don't know the answer. So not knowing is the most exciting time for a mathematician or any scientist. It's like on the verge of making a new discovery, and it could take years and years and years and years and years. So if it takes you a few minutes or a few days, that's perfect, because what we're applying is perseverance and determination. And you've got, and with a desire to learn, you've got a mindset that will serve you in all areas of life. So there you go. And that's, so what are you learning? That it gives you lots of practice in number bonds and building number sense and the what ifs and then what if we did this and we followed on. It's all these questions are giving you power to learn, power to be a great thinker, and power to solve problems throughout your whole life. And then you've got, from a practical thing, what are you doing? You're practicing addition, you're thinking strategically. Strategic thinking, again, is a life skill, something you could serve you well throughout your whole life. And then making connections, that isomorphism, making connections between things that look completely different, but want you to find the connections between them. And then from teachers and grown-ups' point of view, you're thinking mathematically and you're giving explanations. Giving those explanations is one of the best ways to learn. Instead of just going, is it right? You explain why you think it's right. Don't ask grown-up, because sometimes, I mean, I'm wrong constantly. I help my friend Leon, I work with my grandson Leo, different people now. Is it right? You tell me if it's right. Half the time I'll say it's right or wrong, and I'm wrong. So the best thing is if they work it out, or you work it out and you explain to somebody else why you think it's right, and then you can realize for yourself, oh, actually it's not. Oh, okay, and go and look at it. Or you can think, yeah, no, it's good, we are good, I'm confident it's right, and you can work it out together. And then you're visualizing, like when with the symmetry and the reflections. And just generally, just all the activities we've done is all about visualizing and thinking, okay, have I found all the combinations? What are the combinations? Working systematically, super important to see the patterns, working systematically, is super important, and to be happy that you found all the possibilities. And also winning and losing. These games involve winning and losing, and that emotional intelligence that you build by learning how to win and how to lose, because it's not just about how to handle failure when you lose, because that's just a magnificent mistake which you learn from. Also, how to win without making the other person feel bad. That's super important as well. So that person, you can celebrate the winner, and you can it's like, it's so important to hold everybody up, and to help the person who's failed to handle failure, and the person winning not to gloat. Super important. So yeah, so use the activity, and if you love these activities, and there's more follow-up activities at the bottom of the resource, the activity pack, to play more advanced Magic Square. There's an amazing, it's called Jura's Magic Square. Oh my goodness, if you thought the Magic Square you just done is amazing, go and play Jura's Magic Square. And there's another puzzle as well on there. Just go play them. They're such great activities, great summer fun. You doing some fun and learning new things. And if you're enjoying these activities, please do share the lives, share the group, Making Maths Fun for Kids of All Ages. The link is in the pinned post at the top if you need to copy the link, or it's just at the top of the page, the Facebook page. And please do tell other people about it. And if you prefer YouTube, or you know someone that prefers YouTube, or you just generally want to see our YouTube videos, then there's the Maths Toys YouTube channel, where all the videos there are specific to activities on the Aiming High website, which is who provides these activities. AIMSEC puts the content in the Aiming High website, and we use those for these lives. And then there's the Bubbling Maths YouTube channel. Again, those links are in the pinned post at the top of the group. And in Bubbling Maths, you've got the lives going up, as well as other activities with soap bubbles, with balloons, interviews with interesting people who know lots about maths. And I've started to do some videos on mindset, on how to overcome maths anxiety, and whether it's in adults or children, and get us a way of thinking that's really effective for learning. So let's have a look, see if anybody's joined us. I haven't had any comments on here. It's nice. Oh, there are 4 comments. Hold on. Oh, yes, it's a way of thinking that's really effective for learning. Oh, I've got to just silence that though. Okay. So Susan says the 5-letter word game is similar. And how can we make this game cooperative rather than competitive? Nice one, Susan. We'd like to have your ideas on that. And absolutely, it can be done as a team, and you can actually play it as a team, so that you're working out, you can just call it Team A and Team B. It's not you. You can have 2 people playing that aren't Team A and Team B, and each one together you discuss, okay, what should Team A's next move be? What should Team B's next move be? What should Team A's next move be? So 2 people playing the game can work out how one or the other team can win, and work out the solutions there. And whatever ideas you've got, please do. Yeah, got an answer 6, but I don't know what it was. I don't know what the question was when she wrote 6. And then let's see if anybody came on the other live. Oh, Cherry Mosley did. Emilio Lopez, hola, buenas. Cherry Mosley, love you, Cherry. Pindi from South Africa. It's always lovely to see Pindi. Salvo from Southend-on-Sea in England. And Lucy from north of London somewhere. It's lovely to see you all. Thank you for joining us. And that's it for today. And I don't have Leo to switch off for me, so I will do it myself. Thank you very much. I'll see you. Well, we'll be on again in 17 minutes with the early years activity. So that, if Susan, if you're still watching, that if Annabelle wants to join us, then that's very suitable for Annabelle, what we're about to do. Thank you. Bye bye.